So here you are going to learn how to solve the non-homogeneous system of two linear equations in two variables. This is called Martin's rule. First we find the coefficient matrix, coefficient of x in the first column and coefficient of y in the second column. Then we find the variable matrix, and then we write the C1 and C2. Right now I am discussing the questions where determinant of A is not equal to 0. In this case, the equations are consistent. And it has unique solution, which are independent. Now, the equation is AX is equal to B. Now, I pre-multiply A inverse both the sides. And then Ix is equal to A inverse B. And then finally I get X is equal to A inverse B. Since determinant of A is not equal to 0, so determinant of the inverse of A will exist. And then we solve it. This is Martin's rule. So I'll take one example of Martin's rule. First, I have to find out the coefficient matrix. Now, the coefficient matrix, I'll write coefficient of x here, coefficient of y here. Now, I have to check whether the equations are consistent or not. And for that, I have to find out whether inverse of A exists or not. And for that, I have to first find what is the determinant of A. Determinant of A, 3 minus 4. So it is not equal to 0. So since determinant of A is not equal to 0, the equations are consistent and it has a unique solution. Although in the question they are not asked to find the values, just I am showing you how to find the values. So we have got the coefficient matrix, the variable matrix x and y, and the constant. So first I will have to find A inverse, which is 1 by determinant of A into adjoint of A, and this is equal to 1 by minus 1. The principal diagonal elements interchange. And this is equal to minus 3, 2, 2 and minus 1. Now x is equal to A inverse B. So I will write this as minus 6 plus 6, 0, 4, 1. Therefore, x is equal to 0 and y is equal to 1. Don't forget to check 0 plus 2 into 1, 2 and 0 plus 3 into 1, 3. This is the answer and this is Martin's rule. This is a little different question. First we have to find A inverse. So determinant of A is equal to 3 into 3, 9 minus 10. Minus 2 into 5 is minus 10. And this is equal to 19. Now adjoint of A, we have studied, interchanged A 1 1, but both elements are same, and here only sign will change. Therefore, A inverse is equal to 1 by 19, 3, 2, minus 5 and 3. Now, normally what we do, the equations are these: 3x minus 2y is equal to 7 and 5x plus 3y is equal to 1. Now if I write the coefficient of x in the first column and coefficient of y in the second column, and if I compare this with this, you'll find this is transpose of A. If I transpose this, I get this. Therefore, here the coefficient matrix will be A transpose. The variable matrix will be x and y, and the constants one I'll take it as 7 and 1. So normally the equation is equal to B, and then I have already shown you x is equal to into B, but you have to use a property here. This is the most important part. X is equal to A inverse whole transpose into B. We have studied this. So I already found the A inverse. So A inverse transpose will be (1 by 19), 3, 2, minus 5 and 3 from here. And then I'm going to solve. (1 by 19), 3, 2, minus 5 and 3, and into B, 7 and 1. This is equal to x and y. So this one, if I calculate, 3 7 is 21, 21 plus 2, 21 plus 2, 23, and minus 35 plus 3 is minus 32. So here I get 23 by 19 and minus 32, minus 35 plus 3 by 19. Therefore, x will be equal to 23 by 19 and y will be equal to minus 32 by 19. This is the solution. Now, application of determinant and matrices, we are going to solve linear equations in 3 variables. So we find a matrix A. The first column consists of coefficient of x, second consists of coefficient of y, and third consists of coefficient of z. This is called a variable matrix, and this is called the absolute term D1, D2 and D3. So there are 2 cases when determinant of A is not equal to 0 and when determinant of A is equal to 0. Now in this video I will be discussing only this type, case 1, when determinant of A is not equal to 0. This is the case when the three equations are consistent and they have a unique solution, x, y and z. About case 2 I'll discuss in the next video. This is the method Ax is equal to B, and then left hand cancellation law, we get x is equal to A inverse B. I'll show you this with some examples. Determinant and matrices can be used to solve system of linear equations in 2 variables and 3 variables. I've discussed one question here. Question number 4 first. These are the equations. First you have to write a matrix A. The coefficient of x in the first column, coefficient of y in the second column, coefficient of z in the third column. It's a variable matrix. The 3 variables x, y, z and written in one column, and B is the constants here, 6, 12 and 1. First we have to find determinant of matrix A. If it is not equal to 0, that is it is non-singular, only then it is consistent and the solution is unique. It has a unique solution. So this is very important first. Since the value is -8, it is non-singular, it has a unique solution. And then we start with the solution. Ax is equal to B. X is a variable matrix. Left hand cancellation. I multiply A inverse on the left hand side. Both sides on left cancellation law. Then by associative property, this is I, x is equal to A inverse B. A inverse is 1 by determinant of A into adjoint of A. Since this is not equal to 0, the inverse exists. So to find the adjoint, I have to find the cofactors of every element, which I have done here. Then I find the adjoint of A. A inverse 1 by determinant of A into adjoint of A. X is A inverse B, already we have calculated. A inverse B, and then the calculation is done. This is how we find the value of x, y, z using the concept of determinant. Children, this is very important question. Here we have to use the product of AB to solve the equations. And if you multiply AB, you will get a very different kind of result. You get this. We know that the product of matrix and its inverse is I. So from this we can get this, and from here we get this. So inverse of A will be minus B by 8 or minus 1 by 8 into B. Now to solve the equation, variable matrix, this is 6, 12, 1. 6, 12 and 1. X is equal to A inverse C. Directly we get inverse here. That is minus 1 by 8 into B. We don't have to find inverse by conventional method. And then by solving, we get the required answer. X is 1, Y is 1 and Z is 3. So here, this step is very important. This step is very important. Inverse is this. So this is very important for your exam also. This is another very special question. But first we have been asked to find inverse. So we are going to find inverse by normal method. We find determinant of A, which is not equal to 0. It is not a singular matrix. Then we find its adjoint, and then we find its inverse. The first step is to find the inverse. We have done. Now if you look at the equations and A that is given, they are very different. Normally in the first row, 1, 2, 1 should be there. Second row, minus 1, 1, 1 should, but it's very different here. You'll find first column contains the coefficient of x, coefficient of y, coefficient of z. And second column consists of coefficient of x, coefficient of y and coefficient of z. Similarly here also. That is, if I transpose this, then I get the matrix which I want. That is 1, 2, 1 in the first row, minus 1, 1 in the second row, and this is the third we want. That is what, this is what we have to get. So this should be the matrix. Instead of A, we'll take A transpose. This resembles the equation. This is a variable matrix and this is B, which is 4 0 4. This is 4 0 and 2. Now here this property, this law is going to play very important. We have done this. A transpose whole inverse is equal to A inverse whole transpose. Therefore, I can write here A transpose whole inverse is equal to 1 by 10, and then I'm going to transpose this, because we need the inverse of transpose, because the transpose represents the equation. And then we write the transpose of the inverse of the transpose matrix, and then we solve the equation normally. So remember, this is a very special question, because here this is going to play very important role here. This, please go through.